Welcome to Programming with Qt Widgets. In the previous episode, we saw how to implement a tree model, a subclass of Q abstract item model. But maybe, well, just maybe, your fingers still will not spit out such a subclass for you. That we'll address in this episode, where I will implement from scratch a subclass of Q abstract item model. You might wonder what is up with the quality of his camera all of a sudden. Don't worry, it's just going to be this episode. I'm sitting down now because I tried in previous episodes to actually stand up and code, and that just doesn't work out very well. So I'm sitting down. I'll hopefully be in the corner most of the time, but when I'm full screen, please do bear with us. I'm on my good old webcam camera. So what does it take to implement a model? Well, we saw that in the previous episode. We need to implement row count, column count, data, and we need to implement index and parent. And what I'll be implementing now is an example that actually do come with Qt. You just go to Qt Creator and type in simple tree model and you'll find the example. And it looks like this. I've taken it apart. It's actually an old version of it. I even took apart a long time ago. And I'll start from scratch. I have the code for passing the data to get it into a tree, but everything else I'll write up for you as you watch it. Okay, let's look at the code. I have a main here, and my main is rather boring. You see there's not even anything that is called show on, so nothing will be on the screen if I look at it. But we have this class called forest. And well, it's not even a class, it's a namespace, forest, and it can load in a tree node pointer. And actually what it's loading in is a whole forest of trees. So let's just look at what it does. Load just goes and look at this, file that is compiled into the binary. And let's just go and find that right away so we have an idea what it looks like. It looks like this. And super trivial data for a super trivial model, but it's a tree model, and you can see there's one level here, a level underneath. Down here there's even a third level, and there's two columns. This stuff over here is column 1, and this stuff over here is column 2. There's even some blank rows in there that we do not care about. We have some code, and let me just find the code here. There it is. We have some code for reading this in. And let me just very fast walk you through this code here so that you get an idea. I need this one. This is the index above my tree. I need something to represent that. And sometimes I do not have that something available and I just need to make it up. But here, what I'll do is I'll simply create an item here. So what I'm building here, and maybe, yeah, let me do that. Let me just run. No, let's not run it. It's very boring to look at when I run it. Let me go over here in main.cpp and put a breakpoint here and debug it instead. That's the interesting part. So when I hit this breakpoint, I already created my tree. And if we just see my forest here, you can see it has some column data. It's a node. My forest is a tree node. So it has some column data, title, and summary. If I just see if I can go over here and resize things slightly so you can see better. There we are. Okay. So at the top, I have title and summary, and that is the data that I have for my two columns. This topmost element here, it has number of child node. It has 6 children. And if I just go over here and find this one here, you can see 1, 2, 3, 4, 5, and 6. And I'll bet you that you'll find those. Let's just go to the last one. So it has column data here, connection editing mode, and something very long here for the second column. So I simply build up a tree of these data structures, and the data structure for my node here is relatively simple. Basically, I have a list of tree node pointers, and I have a string list for my column, and I have a pointer to my parent. And then I build up this tree, and somehow my computer do not work anymore. Control tab will not work for me. So let me just fix that. How about you get to listen to the colorful Jesper in between. Are you developing Android software with Qt? That seems rather mental. Unless, of course, you have a desktop application and you just need an interface on a phone for that system. In that case, yeah, it does make sense. Unfortunately, KDAB has you covered if there are tiny tweaks that is not trivial for you. Okay, back to the code for loading here. It takes the load up here, it reads out from this file, it opens the file, it splits it at the new line, which means that I'll have a list of strings, one line for each entry in my default text. So this is one line, and so on. Well, the whole line. And I give that to another load method that returns my tree node. It creates this artificial one at the top, which is going to be the result. And that's the forest that you see up here, which has all the children. And for one of the children, there might be other children, as we saw. So that's the two children underneath the top row that we have in our model. And at the end of this, so I use a stack to get those things created. It's pretty self-explaining, this code, and not really what this is all about. So read the code on your own time, and let's get started implementing a model. So I'll go here. I need to implement the model, so I'll go to Qt, and let's see, Qt item model at the very top. I can never find things that is at the very top. Qt item model. We're going to call it tree model. And it'll go into tree model agency pp. Can I customize the header rows? Yes. Items are editable? No. Rows and columns and can be added and fetched? No. And that will be it. Go into this one, and that's all fine. And here is my model. And I seem to remember from a previous live coding that there is a trick in here around is valid, but we'll get back to that. My model, I need now to create that. So tree model, and my tree model is just created here on the stack. I will give it the forest as the parameter here. Give it the forest as a parameter, and I need a QTree view, and the view needs to have the set model, and the set model will be this model that I created here. And I need to show my view dot show, and I'm sure that ChatGPT has lots of other suggestions for me, or GitHub Copilot has more suggestions for us. Let's just resize it here to something saying 800 times 600. Otherwise, we're going to be looking at something very boring. Let's try and run it and see if it actually works out of the box. Who knows? We might have our lucky day, and there's a lot of errors. Tree model. Well, first of all, I need to include my tree model. Sure. Include that one. I need to create my tree model over here that takes a tree node root. Need to include that tree node. There we are. And m_root. I need to go down here in my private section, tree node pointer m_root. So that's my data structure that I have in here. Node pointer. There we are. And let's see if that compiles. Still doesn't. Tree node doesn't. Explicit tree model. Oh, tree node pointer root. Now compile. Seems like it's not my day for typing stuff in. Tree node, unknown type tree node. Didn't I? Oh, that was over here. Well, let's forward declare it up here. Class tree node. That's a typical development cycle for me. Doing just the tiniest little change I can get away with, and then compile a tiny little change more. And this time I'm trying to just get my very simple thing working here. I forgot to include that one. And just in case that you're wondering what are all those magic keys that he's typing, well, let me point you to 2 episodes in Qt Widgets and more. There's one for all the magic keys bindings in Qt Creator, and there's another one for GitHub Copilot, how to set that up in case that you have not done that. We are ready to run, and here is my tree model, and it was not my lucky day. It didn't just work out of the box. Okay, let's get started with our tree model. It already implemented a lot of stuff for me, or suggested a lot of stuff. Let's just see what it says. Header data, certainly I want that. Index and parent, they were the 2 that I do need. Row count, column count, and data. Yes, these are all the functions that I need. And just to get a feeling for getting started here, my header data, well, let's just implement that. If the orientation is vertical, well, if the orientation is horizontal and the role is display role, that's perfectly fine. That is what I know how to do. Otherwise, return an empty string or an empty variant. So I'm asking for my orientation. And if we go over, remember when we created the data structure, my node structure here, it actually do have at the very top, I have information. So I have data here for a given column, and I can actually call that. Sometimes that is, most of the time, that's not the case. Most of the time it would do just like you saw in the implementation of my table. It might be just saying if column is equal to 0, or if it's equal to, and then the enum for the first column, then return that. But here I actually can just say m_root, and then dot, that's a pointer, data for section. And let's see if that works. I believe it does. Bummer. So why is that? Well, that's because I did not tell it how many columns there is. So I can go down and say, column count. Where is that? If the parent is not valid, that's above the tree, then return 0. Otherwise, return. I know that my model really only has 2 columns, and it always has 2 columns, so I can just say return 2. And now drums, title, and summary. No rows still. And this is where things get difficult, because the next thing I need to implement is likely, well, it's row count, it is data, it is index, and it's parent that I need to implement all 4 of them before I see anything on the screen. And one solution to that might be to go to my main and say, okay, forget about the Q3 view sitting there. Now instead, I'll simply unit test this. So I'll go and ask my model, can you give me the data for the QModel index, open parenthesis, close parenthesis, this one. And hopefully the model will say, I don't have any data for that, neither for display role nor for anything else, because it's not a valid index. And then I can go, the next line in my unit test could be, hey model, can you give me an index for row 0, column 0, this one, and I'll get one of the real indexes back. And at that situation, I can then continue on. An alternative to that is just to brute force write it, which I'll do now. But then again, I've done this a million times before, so I can get away with it. You likely will not be able to get away with it your first few iterations, so do remember that trick of implementing some kind of unit test in your main.cpp. Okay, row count. How many rows do I have? Well, that depends. If I go over and look at my my default.text. That's what I have here. Well, at the top I have 1, 2, 3, 4, 5, and 6. But if I'm underneath this one, then I have 2 rows. And if I'm underneath this one, well, then I also have 2 rows. Here it's 3 rows. So it depends not only on my current row, it also depends on the parent. Okay. And that is where I now will teach you a super awesome trick. Because what you need to do from now on is that you need to go from a model index over to my internal pointer, which I know for a fact is a pointer to a node item. That's what it was called, right? No, tree node. So this is a model index, and inside that model index, tree node pointer. If I can just get to that one, then it's so much easier to answer. And that's where I'll go up here and I'll write namespace. And I'll implement a tree node pointer, and it'll call the tree node from index. It'll take a const q model index. And let's hope that that GitHub Copilot will not implement it for me, because at least not before I've told you what is going on. Well, I know that when I create the index, of course, I'm the only one who can create the index. And when I create that index, what I'll put in here is a void pointer that represents that model index's tree node. So all I need to do is say index.internal pointer. Internal pointer. There we are. That will give me a void pointer. And I need to static cast that. Static cast that to a tree node pointer. Like this. So I take my internal pointer and I static cast it to that. But now hopefully you'll be asking already, but Jesper, wait a second. How about this one? This one is not a tree node pointer. But what does that represent? That represents the above tree item. So in here I'll say if my index.isValid not, that is this one here. Well, in that case, I will just return, I cannot type return m_root, because that was the beauty of the whole thing. I set up my tree so that at the top of the tree, I had something that was the same data structure as everything in my tree. And obviously it's not called, well, it is called m_root. That's why it can't be a namespace here. Jesper. Else return this stuff here, and I'll just take it over here. Go over here in my private section and do this little magic key binding here to move it to my implementation over here. Tree node from index. So tree model, tree node from index, given a model index, if it is at isValid false, is this one, then I'll return the root. Otherwise, I'll return this, and that's all cool. Because here's the beauty of it now. Row count. I'll show you how easy it is to implement row count. I will go here, tree model row count. Forget about all this. If you're asking me for row count for this one here, could be this one, could be this one. What I need to do all the time now is get an index in. All I need to do is just say whoopty, and I have my internal pointer. That even works for this one here. Say whoopty, and I have my internal pointer, which is just m_root. So in that situation, I'll simply say, now let's say tree node pointer data equal to tree node from index parent exactly. And now return data.child. It's too easy with ChatGPT or with GitHub Copilot, but you can see over in my tree here, there is actually a child count method, and the child count goes through and return the number of children there is inside of this one. Yes, that was a enormously lucky punch that it had that method. Usually it wouldn't, but again, this whole tree node class here was built up to support this example here. But let's just go over one more time and see. I am coming in, child count on the tree node here in my tree model. I'm coming in and I'm asking for how many children do we have at the top. So how many children? That was this 1, 2, 3, and 1. There we are. 3, 4, 5, 6. Really, Jesper? How did that work? Well, how many children underneath this one? So parent is the QModel index, parenthesis open, parenthesis close, the one that is valid not. So I'll just return my m_root. And if you remember from the debugging session, the m_root was exactly pointing to, and let's just go to our forest here. Forest.cpp, my very top tree node that we created from this was the one with title and summary. That was the very first one. And this one, let's just get the debug up and running again. Oops, there we are, debug. Let's hope that it's in a debuggable state. It is not. Well, that we can fix really fast. So, and discard tree node as index. Make that const, please. Okay. Over to our main.cpp. I just want to break right here when I have created my forest. Because now you can see at the forest here, the very top of that tree, the one thing that, well, let's debug our way in. That's the one that becomes m_root, the one that comes in. And my root here, child count is exactly 6. The column data for this one was title and summary. That was what saved our day when we did the implementation for header data. Where are you? At the very top. Root pointer m_root data. Title and summary was in there. So that's how my row count works. If I come in with this one, it'll go to my m_root. If I come in with anything else, given that I implemented correctly, which I haven't done yet, but given that I implemented correctly the index method, if I come in with this one, I will open it up, take out the void pointer, the internal pointer, that's what we have down here. Take out the index.internal pointer, the one that I put in earlier on, in the future early on. Time travel is a difficult thing. And I will cast that void pointer to a tree node. And now I have a node that represents somewhere deep, deep down in my tree here, represent one of these rows. Column count, we already implemented that. Let's implement data. That is also super easy. I actually do not even need this, but if I go, usually I would have this. If you go and ask for data for an index that is not valid, that means that you ask for data for this one. I would be able to answer that already because I do have the what is it called, the title and description inside of this one, so the API even works, but otherwise it usually doesn't make sense. Will Qt come and ask for that? Q model or Qt view? Likely not. But remember from the previous episode, there might be a broken proxy model sitting in there. So if you go and ask for data for index is valid, I'll just return nothing. But if you ask for something that is valid, well, I was just about to go up here and cut and paste because it's the same thing that I'm going to do again and again. You come and ask for data for this one here. Ooh, I don't know what to do about it. Oh, I do. Whoopty, open up. Here is my tree node. And I know how to get data for that because, again, my node happened to have a method called data for a given column. And how did I know? Because I looked at the API just a second ago. But see here, in my setting up of the node, I have the m_column data. That's what we have here. This is just a QString list, and the QString list has an API for getting the data for the columns, or the columns row in that, or index in that string list. So getting that out here, and I am good to go. Okay, we just missed two trivial methods to implement. We need to implement index, and we need to implement parent. Implementing index. Fix me, implement me. Yes, you are very kind. How do I create an index? Oh, stop it. How do I create an index? Well, I do that by writing create. I think I will go and ask my little friend GitHub Copilot to shut up now. I will be writing create index. That's the only way I can create indexes, except this one here. This one I can create by qmodel index parenthesis open parenthesis close, but any of the others I need to call create index, which is a method on my superclass. And this method on my superclass, it takes a row, a column, and a pointer. And now the question is, what is that pointer? Well, if I have somewhere deep in my tree, I have a pointer. You can see a pointer to whatever I have. So all I need to do now is to go and find my parent item. So tree node pointer parent node. That, how do I get that? Yes, you are entirely right, and thank you for not typing it out for me, because now I need to type tree node from index parent. So now I'm asking for an index for the row, the column of this little fellow here. Well, what I'll do is that I'll go and open it up. Here is a tree node. It might be that tree node that represents this one over here. And I need to go and ask for my children. I need to ask for the 2, if I want to get to this one here. So all I need to do is I need to go and say tree node pointer equal to parent node pointer, and I'll bet you that it also has a child at a given row. And let's just look at what child does here. So it goes to m_child nodes, that's what I have over here, and it asks for the one at row. So this second one, that will now give me a pointer to that particular item that I have here. And my method index needs to create an index. So given this parent, row number row, column number column, can you give me another index? Yes, I can. Create index, and in here, I'll just put the row and column you asked for, and then the pointer that I calculated. And we're almost done. We just need to implement one more method, namely parent. And how do I create my indexes? Well, create index, that's the only way I can do that. And create index row, comma, column, comma, pointer. And I just need to figure out what they are. Actually, remember, I started out the previous episode by saying this is a tree model, it's a 3-dimensional, not a 3-dimensional, because I do not have anything under any other column than column 0. So that's a 0 here. And then the row and the pointer. Well, first of all, I need to get my data. So tree node pointer, my node this time is again tree node from index of index. I'm asking for the parent to this one. I'm sitting here, so I'm saying dear node. Oh, again this way. So what do I need to do? That's the sound effect. I need to just go and say open up. Oh, you want an index for the parent of this one. That is super easy. that is, I need to go and fetch and now I definitely need to go and look at the API of my tree. It has a way to get to the parent node. Awesome. So tree node pointer parent node equal to my node dot parent. Absolutely not dot pointer parent node. So that's the pointer that we have here. You go down there. Now all I need is the row. And what row is that? Well, again, we are saved by the bell in the tree node because it has a row. So I can simply go and say parent node pointer row, and that's the row. What did row implement? Well, actually, in classes, I've done this exercise a million times in classes in a slightly different setup, and it doesn't have a tree node. It has some other data structure. And there, what you really need to know is that I need to go from the child, can you see that again? From child to the parent, and I need, for the parent, I need the internal pointer. That was easy, that was just my parent's pointer. Column, that was the column. But what I really need is the row that my parent is in its parent. That's what we can see here. If I have a parent node, then return go to my parent's parent, so that's my grandparent, and ask for its children, and then ask for, that's my parent, this is my grandparent, which index are you in your parent? That's what we return here. And now I'll definitely have a cut in the video sequence, so the next frame you'll be looking at, I'll be somewhere else, and my whole editor will be somewhere else, because I have very surely made at least 20 mistakes that are just trivial. I'll fix them up right now. You won't believe it. There was not a single compile error, but fortunately, it did not work. Let me just show you. This is what I looked at, and this is exactly what you will see the first many times you try this out, because if one of the methods is wrong, nothing will show up. And I actually did spend 10 minutes, I think, figuring out what went wrong. Let's just build it again. Well, nothing changed. There we are. Build it again, because the first error, I actually get a warning here. So always careful with your warnings. So it says in tree model here, it says parent is not used. Well, that's okay. That one I can just ignore because I said it's always 2. Next error. The next one is down here. It says unused parameter row. And that's where I need Robert to help me. Robert, can you help me?
USA.
Yes, I remember. That is the indication that I did not check for the row. So my view said, hey, can you give me the text for this index? And I said, yes, that's USA. It's from a model I do in class usually. There's no USA in this here, but just imagine. Play along, will you? Okay. It says, will you give me the foreground color? USA. Background color? USA. And so on. And eventually, it will ask me for the size hint. I'll say, let me see. That's going to be USA. So that's 0 times 0. That's the first reason why I don't see anything. So I should check whether it's an invalid index or the role is different from display role. In that case, just return nothing. And that worked out pretty well so far, except that now that I run it, it crashes. That's what coming up on the screen, not working anymore. So let's debug it here now and see what is going on. So in the tree node row, it asks for something on this being null pointer. That's never good to ask for instance variable of a null pointer. So let's go up. So I go and ask for parent node being null pointer. See, that's a problem with parent. I need to be super careful about when do my recursion end. I often write this line here, which is not needed because I will have ended before that, but saying if the index dot is valid, not. So I'm asking for the parent of my ball pen here. What's the parent of this one? Doesn't make any sense. In that case, return nothing. But that would not have helped me here, because that step in my recursion is not good enough. So this one is sitting just underneath the parent. So I go and I ask for a my node. My node now returns something valid, and then I go and ask for the parent. But do my node have something in there? Well, my node will be the that will be a valid one, but I'll go and ask for the parent, which will be this one here, valid too. But my row, remember my implementation for row will go one level too far up. So in here, I always have a hard time fighting this. Tree node for the very one here. If that one, no, it must be the parent node. So I'll say if my parent node is equal to m_root. That is, if my parent is this one, then let's semicolon return the empty element. And drums. And there it is. Now my model works just fine, and I could start adding other roles to it, like foreground and background color and whatnot. But the hardest part is to get these things working. So let's do a recap of what we did. Step 0 in all of this is to understand your data structure. Once you've understood your data structure, how do you traverse it? Sometimes you do have a tree. In our classes, we have another exercise in this one where we are implementing a tree model for the parent-child relationship of a widget hierarchy. Pretty similar to what Gamma Ray does. And if you haven't heard about Gamma Ray, here's a link that you can go and look at Gamma Ray at some point. I need to be careful all the time. I have two different kind of indexes. QModel index, parenthesis open, parenthesis close, and a QModel index looks like this, but I can turn it around and I can pull out my representation of my data structure. As I said, sometimes I have a complete tree, but not one where I can add helper methods like row that we saw. Sometimes I don't even have the tree, but I need to build up the tree on the fly. Just be careful that every single time you ask for the index for a given pointer, it must be the same index that you return. Meaning that what's inside there must, of course, be your pointer. Anyway, the very first thing, always when I need to implement these, is go down here, implement this tree node from index, satellite data from index, QObject from index, depending on blah blah from index. Blah blah is what your data structure is about, the part that you know how to navigate. And once you got that, the rest of it is, I would say, relatively straightforward. Not trivial, but straightforward. We will always start with implementing the header data, because that is super easy. That seldomly has anything to do with the data structure. I could just have tested here. If it's column 0, then return title, column 1, return description, and that would be it. Now down to the implementing row count and data. That's what I usually do. Well, column count again, return 2, but if there was a different column counts, depending on the actual data, I would need to implement that. But the row count, it goes like this. I have this index here. I need to know how many children. Well, I'll take that pointer, the pointer representing a data structure for my data. I'll take that out. And that's what my tree node from index does. Now I have a tree node. And tree node, yes, I know all about those. I can go and look up at the API and I will see I have this tree node. Conceptually, it has a number of number of children, or not even conceptually. Sometimes it has, as in our situation, real children, I'll go and count how many children it has in the world of tree nodes. That I know everything about. So tree node, child count. Data, similar thing. There, I definitely need to remember to look at display role. Sometimes I need to look at whether it is this one, because I might not have my tree node from index return me something where I actually have something that is the same thing. It could have returned a null pointer or something else. Okay, with that in place, my data method, I go and say again, ta-da, open up, I get my tree node out. Oh, you want to know what is at column in that tree node that I have there. It has a data method. It has maybe not a data method in the example that we have in our trainings. We have 3 columns. One is being the pointer address, the other is the class name, the third is the object name. So depending on the column, I will either go to the objects, the Q object, and ask for object name, or go and figure out what class it is or where is it in memory. But in any case, I'm in the domain that I know everything about. And now implementing index and a parent, I'll go and get that parent here. I'll fetch out, and maybe depending on my data structure, I need to test whether the parent is the topmost one. I could have done here, if the parent was empty, then I would operate, then my parent node would be m_data, which tree node from index does for me. Otherwise, I would go and call tree node from index, which is doing again. Now I'm in the land of that, and return create index row column and pointer. Row and column is here, and the pointer is just go to operate my data structure, figure out what is the rowth child of my data structure, get that into a pointer, and that's the API that we have here. And finally, the parent one, I obviously did it on purpose. You can go and figure whether that's true or not. That I had the mistake of not testing the boundary condition. This one up here, I'll never get to that situation. You can reason why yourself. But if I go and ask for an index from, or I'll go for this index here, go and find that. Now I'm over in the land of my tree node. I need to call create index row 0, 0 and parent node. And row or parent node, that is just taking my parent, whatever data structure I have here. I need to find the data structure. Yes, I did get my fingers black now. The data structure I have for the parent up there. And that's what I do here. Go to my data structure, figure out the data structure for the parent. And that's my parent node here. And now I need to go. I need to go and find my parent's parent and figure out which row I'm in there. We fortunately had some API in here, namely just the row, for figuring that out. And it's always that situation. I am sitting somewhere here. If I am asking for the parent for this one here, this is a valid one. Now I go and ask for the parent. And what I get out of that is this node that represents this one here. And if that's the case, then return the empty the empty Q model index, parenthesis open, parenthesis close. Let me end this episode with a word of warning. You likely have forgot it, and when you finally hit that, you will certainly have forgot that I gave you this advice, but just for the full understanding of what's going on. I've seen a lot of people trying to implement parent, and they ended up somehow getting to the Q model index class, and they said, ooh, Q model index has a parent method, so when I need to implement parent for a given index, I'll just go and ask that index for the parent, and ta-da, it's working. Well, let me show you the parent method. It says, if I have a model, then I'll go to my model and ask for the parent of this index. So that's not the solution. The reason why we have the parent method, the reason why we have all of these different methods here is that when you are in the land of implementing, say, a delegate, and you need to get some data, you already have an index rather than go to your model and say, hey, model, can you please give me the data for this index here? Then you can go straight to the index and say, hey index, can you give me the data for, say, the display role? And right away you have the variant there. I was hey model, that was what I was trying to say before. Can you please go and give me the variant for the display role for this index here? I'll try a third time. Hey model, I'm in a delegate now. I have an index, and I could go to the index and say, index, which model do you come from? And then I have the model, and I can go to the model and say, hey model, can you please give me the display role for this index? That's where it's shortcutting with the data method here, for example. If I have a model, then model give me the data for this role of myself. So in my delegates, instead of going and fetching the model and getting the data, I can just go to the index and say, hey, can you please give me the display role, which happen even to be the default parameter for this index here, and I'll get the data. Just a simple shortcut. Wow, that was truly it. Now you have seen a model being implemented, a real Q abstract item model for a tree. Everything else is exactly the same from now on. You have your own data structure, either in memory or elsewhere. You need the my data structure from index, and once you have that, you can navigate your own data structure. As I said in the very early on in this episode or this series here on model view, it shouldn't have been called model view. It should have been called view / interface to data, whatever, because that's what it really is. Your model is just a translation layer to your real data, so that we can communicate between the view and the model through abstract terms like a Q model index. This one is for satellite data, or a Q model index. This is for tree nodes, but you can't tell, the view cannot tell the difference because it's hidden inside of those. And do remember, and I've taught this like 100 times by now, to remember the trick of mentally thinking, whenever I see a Q model index, I need to turn it around and get my data out. And as soon as I have my data out, the question is way easier. That's it for this module of programming with Qt Widgets. In the next module, we will continue talking about model view, because we have quite a few things we haven't talked about yet. We have proxy models, we have delegates, and we have some other, the views themselves, how can they be customized? But you definitely learned enough for now to start being really dangerous with model view. You might not have the proxy models and the delegates, which are the really true important things to learn about. But hey, stay tuned. Give me a thumbs up because you thought I did an excellent job in explaining this, and give me a subscription so that you know exactly when it's time to learn about proxy models and delegates. And until next time, have a great time.